All right, so let me see if I can get an idea from each group. Front group up here, give me something. Methane. With cow farts, right? Methane, we've heard of that. Kern's group. Say again? Propane, like a propane tank. Who's got a propane tank at home for like a gas, a gas grill? Right, or some other propane tank for fire, okay? What else? What's this group up here? Ethanol, right? Ethanol is what yeast poop out. We use it for various purposes. Corbin? Where have you heard of octane?
I'm sure using some fuels.
Yeah, so octane and octanol are two very, very high energy compounds that we can use in fuel, like gasoline. So like where it says 92 and 87 and the high octane gasoline, who puts the highest octane into their cars? Like the high functioning engines. Us normal folks don't have those kind of cars, so we probably use them like the lowest grade octane because our engines don't process that, okay? So keep your computers shut for me. They will update on their own. Thank you. Or kind of like halfway closed. All right, so basically what I'm showing you is this new form of nomenclature that's organic because everything contains what inside of it? What's organic mean? Carbon, right? It's going to contain carbon. So carbon is a very predominant element within these types of formulas or compounds, so we have to name them very specifically. Everything we've been doing so far has been inorganic. It's not, like carbon's not our primary element. So if you have one carbon, you say meth. If you have two carbons, you say F. 3 carbons, prop, 4 carbons, but, pent, hex, hept, and oct. Those last ones are very common to what you've been experiencing before with prefixes with covalent. The first 4 are the random ones that you have to kind of know and memorize so that you're not thinking, okay, what's 2, what's 2, what's 2? It's not bi, it's F. So you guys kept saying this, or you kept saying ain, ain, ain. So ain, een, and ein. So I want to underline those or highlight those on your notes. Some of you guys are listeners, and I just, it gets some of the stuff saying when I write something down, I feel like you have to write something down for some reason. Okay, so ain, een, and ein. Essentially, you can have something called like propane. Propene, as it ends in een, or propine, as it ends in yne. So you have to be very you have to enunciate your words there very well, or your endings. So the idea is that everything that's an ain, this is helping describe the number of hydrogens in the compound. Ains, enes, and eins helps describe the number of hydrogens in the compound. So what we do to determine the formula between the carbons and the hydrogens, this is called a hydrocarbon. The way we determine the formula is we look for the prefix that gives us the number of what? Carbons. And then we see the ending is ain, een, or ein. We use this little formula, 2n plus 2, 2n, or 2n minus 2, and that helps us determine the number of hydrogens, where n is equal to the number of carbons. Okay, so n is the number of carbons. All right. So I'll tell you more what it looks like structurally in a second, but let's do a couple of examples. So if I give you a compound called hexane, okay, what's the prefix you see? Hex. Okay, Jacob, what does that hex mean? Good. Okay, so I'm going to put C6 to represent a subscript of 6 would indicate 6 carbons. And everybody, ane refers to the number of hydrogens, right? What's the little formula?
2n plus 2.
2n plus 2. So what's 2 times, what's our n number here, guys? 6. Okay, so that's going to be 2 times 6 plus 2 is equal to what? 14. So then all we do to conclude our formula is write C6 and then H14. And that's hexane. So that's a pretty long one whenever we draw the structure out. So on your, in any of your hydrocarbons, you have a big long string of carbons and you have a bunch of hydrogens surrounding it. So structurally it's going to look like this. Carbon bonded to carbon. How many of these do you think I'm going to have? 6, right? Carbon, carbon, carbon. Okay, so drawing it with me here. We got carbons galore here. So currently around each carbon, how many electrons have I indicated? How many? A lot of them, like this end one, yeah, I only have 2. But for example, this carbon here, right here, how many electrons are around it? 4, right? 2, 4. So how many do I need? How many more do I need there? So I need to attain what rule? Octet rule, right? Okay, so I'm now going to surround these with hydrogens to get to octet on everybody. So all you're going to do is you're going to fill in 2, 4, 6, 8, right? But these are not going to be carbons. These are going to be hydrogens. And I want you guys to finish this up. Make sure everybody has octet. Aiden, are you done? Tell me how many hydrogens are present on your structure.
14.
How could you verify you're correct?
There were 14 hydrogens in the fourth one.
Good. So there should be 6 carbons and 14 hydrogens. So I do not require you to draw them every single time, but I want you to be familiar with these compounds called hydrocarbons, because they're very, very useful in your life. What biomolecule, remember those biomolecules from biology? Give me one biomolecule from way back biology. Like macromolecule, the 4 main biomolecules. Nucleic acids, give me something else, Kendall. Lipids. Who else has got me? Carbohydrates and proteins, right? So those are the 4 biomolecules. This one is supposed to resemble more so. This is supposed to resemble either a carbohydrate or a lipid. Of course, there are some options that are going to be involved on those, but this is something maybe you've seen before, but as a biological application, not a chemistry application. Okay, so let's do a couple more. I want you guys to write the formulas for propane, pentane, butane. Start with those 3, okay, and then I'll do another example. Propane, pentane, butane. Now, give me a heads up. Whose computer is still updating? All right, so get ready. I'm going to ask for your help on these, okay? Somebody might help you out if you need it. CJ, get me started on how you break this compound name down.
So I looked at the front, it says
Prot means,
3 carbons.
okay? And then keep going.
And that's all it says. It said 2 N plus 2 carbons, so like 3 times 2. And add this one to it, and I got
H8. All right, so pentane or propane is C3H8. Ariane, pentane, the second one, help me out here. Get me started on how you break this down. Good. So 5 is for pent, and then 12 is coming from the adjustment for the hydrogens. And then how do you guys say the last one? Butane. No one says butane, right? It's butane. That's kind of weird. It always makes me giggle when you guys say butane. But Kern, get me started. But means what? 4. So I put C4, and then finish that up. This is a 2N plus 2 because they're all in an ane. So then how many hydrogens should I have? H10. Okay, so I'm going to adjust all these names to not be anes, but to be ines. So when I say ine, am I saying Y or E? Y, okay, so propine, pentine, and butine. Get your formulas. All right, Cole, get me started on the first one. Approach means what? The prefix approach means what? C3, okay? And then the ion indicates to do what for hydrogens? 2 and minus 2, okay? So what should this be? H4, good. So it's 2 times 3, that's 6, minus 2 is 4. All right, next one off, second one, or pentime. C5H what? H8, good. Butine, Jacob?
C4H6.
Good. And so what we're just approaching is looking at how we can name, giving a prefix and a suffix in an organic fashion. We could draw all of these too. So I might get into some more of the drawings tomorrow, but I wanted to show you one more thing for today. And it was an alcohol. So when you see an OL on the end, that's the last column in your table, right? Okay. When you see an OL on the end, it means it's an alcohol. Alcohols have an OH ending. So the alcohol indicates that it has an OH ending instead of just a hydrogen on the the end of a carbon chain. So every time what F refers to? C2, good. So that's our second prefix, which is 2 carbons. And if it were just simply ethane, what would the formula be, guys? So C2H6. Okay, so draw that out for me. This will be a quick one. How do I draw this? Bailey, get me started.
C2.
So 2 carbons attached to each other. Yep, so there's a carbon chain, so 2 carbons attached to each other. And then what do I need to do for all my carbons? Say again? So we're not drawing ethanol yet. We're going to draw ethane. You can see the formulas here. We got that so far? Right here?
Yeah.
So I gotta give everybody octet, right? So this is a single bond situation. So if I gave everybody octet and hydrogens would attach here across the board, how many hydrogens do I have, guys? 6. So that's definitely ethane. So what I'm going to do is I'm going to adjust this, and notice I've taken the E off and put an OL for ethanol, and one of the H's comes off, and I put an OH in its place. So I'm just going to do that on the end over here. Swipe away this H. I'm just modifying ethane to show you how the alcohol is very similar. It's just an OH ending instead. And you're going to attach an O and an H. Now you guys know bonding. Like this is octet, octet. Does oxygen have octet? What do I need to do, Corbin? I can't add more hydrogens because the formula for ethanol is C2H5OH. Sorry, I never actually wrote that for you guys. So I can't add more hydrogens because I've exhausted them. They're here. So instead, how can I approach this giving an octet? That'll modify this one's octet and give it 10. Raise your hand if you can see where I'm going here. Ooh, crickets. How normally would I potentially not modify the structure? Lone pairs. How many lone pairs do I need? 2. Boom, boom, done. Thank you. So essentially, that's still you showing octet but with lone pairs versus bonds. All right, give me a thumbs up if you can get on Socrative now. Let's try that again. I didn't want to waste time, so I just modified it a little bit. Give me a thumbs up if you can get on Socrative. You've got the power. Okay, so you got a periodic table out. You know what these are concepts. Now we're going to talk about. I want you to do it from your brain. Make some mental notes on what you need to study. scratch paper, of course, I'm not going to deny you that for like crisscrossing and things like that. You can't do that in your head. The hydrate one. Do you know what I'm talking about with the water in it?
Yeah.
If you have your problem set, you should have it out with you now, okay? Keep a hold of that for a moment. Memory, it was COSO4.H6H2O, yes?
Yeah.
It was like the third or fourth to last. All right, so we're going to name this one together just so I know that you know how to name hydrates. We will work with hydrates a lot more. Again, you do not need your computer for the moment. You are working with me on problem sets. If I can't trust you on the computer, you don't get to have a computer. Okay? All right, so CO, who is that? Cobalt, right? Oh man, where's cobalt on the periodic table? Transition metal. So what do you always have to get into the transition? The charge, but how are you giving me the charge? Roman numeral. Okay. So cobalt's going to have a middle initial here. It's going to have a Roman numeral. We just got to figure out what it is. So looking next door, you remember this has a first name and a last name. What is the last name, Bailey? So this is the first name. This is cobalt. What's the second name? So is it just S or is it just O or is it SO4? SO4 comes together, right? So that's a whole happy family. Don't be a homewrecker and break it up. It is SO4. So then we're going to leave it as sulfate. Everybody, what is sulfate's charge? 2 negative, right? So then what did cobalt have to be if in the end both of the subscripts are 1? 2 what? 2 plus. So then how do I list that here? Roman numeral 2. Okay, so I think you could have gotten the first part very, very easily. The second part, this is not a multiplication symbol. This is a dot to indicate that this water is embedded in this crystalline structure, this lattice structure. So that is a dot, not a multiplication symbol. Okay, so what we do here is we want to say that this is a hydrated compound. So like if you were hydrated, what have you had a lot to drink of? Water. So this is a hydrated compound. So what we say is cobalt 2 sulfate. How do I say 6 in prefix language? Hexahydrate. Not hexawater. I saw a couple of you guys say hexawater because you just didn't know how to approach that. Now you do. Hexahydrate. I'm going to give you another example. Take 10 seconds in your group. Discuss. The C. All right, so I'm gonna just point and you give me the first or the middle or the end, whatever. Okay, so get me started. Okay, stop. Kindle's area. Okay, I'm gonna put sulfate, but I'm gonna leave a space here, okay? Because this is copper is a transition metal, so we all know it's gotta have like a little middle initial. Non is spread out area. What else do you know? You know it's pentahydrate at the end, good. So penta is 5, hydrate is water. All right, this over here. Why do you say 2? But who does this 2 subscript, who did it come from? That came from sulfate, right? So then what should copper's charge be? Good, a 1, because there's a parentheses technically around sulfate. That 1 technically belongs to copper. All right, so that's just the one random one I wanted to show you. Okay, so we are done with nomenclature, but we're going to use it basically until infinity and beyond. So you have to know your nomenclature so you can approach everything with intelligence and you don't always have to use your cheat sheets in your notes. So what I wanted you guys to do first, this is like first part of your reading guide 10. So I'm just going to get you started on the first 3, and look at reading guide 10 homework tonight. So write down someplace RG10. You are just going to look these guys up, first 3, because this is the premise of our notes today. And we have about 25 minutes, so we're going to see how far we get today. 30 minutes, 32 minutes. Woo. I'm giving you like literally 3 to 5 minutes. So if you want to divvy up, if you have one person look up one person look up another, one person look up another, we're going to discuss these in about 3 minutes. Divide and conquer is fine for this particular activity. I'll get those little yellow cards for you shortly. Don't see them waiting for you.